Today, I am going to demonstrate how to model and solve join and separate word problems. First, we're going to make a connection between the inverse relationship between addition and subtraction, inequality, or the equal sign, and that these concepts intertwine as we are working with equation which should be balanced on either side. The operations of addition and subtraction undo each other, which makes them inverse. For example, 7 plus 3 equals 10. 3 plus 7 equals 10. 10 minus 7 gives you 3. And 10 minus 3 equals 7. These two concepts also tend to be a struggle or cause students to develop misconceptions. The most common misconception is that the equal sign symbol means the answer is, or the answer is coming up, it is time to do a computation, rather than a symbol that indicates equivalent relationships. The misconception is further promoted with the use of calculators when students push the equal sign key to provide them with an answer to the problem. Our first problem, we are going to use a set model. Our problem says, Elise has some marbles. She gave 3 marbles to Dylan. Then she had 9 marbles left. How many marbles did Elise have to start with? This is a separate problem because quantities are physically being removed or taken away. It is important to remember that the set model numbers are represented as a collection of objects. In this case, our objects include longs and units, or base 10 blocks. There is not a commonly used strategy corresponding to the action or relationship described in a separate problem, as it is a start unknown quantity. However, children would generally use counting onto or joining to in order to help us solve this problem. First, let's start with our sequence. Elise had some marbles. We put a question mark under start because we don't know how many some is, but we do know she gave 3 marbles to Dylan. The 3 will be represented by 3 units, which are our change in our problem. Then she had 9 marbles left, and that's our result. That's how many she had left. Now, most kids would use trial and error to solve this. They would try to balance the scale. They would try to balance, if we have 9 in our result, we would want 9 here so that our scale is equal. However, students may not know that, so they may try putting a 1 there or a 10 there, and the scale will be off balance. However, we are going to take into consideration our change, and so we are going to add the 9 over here. It might take students with minimal understanding a few tries using trial and error to get this first part balanced. But we can also make a connection between subtraction and forward counting, as now we are going to count forward to solve this problem. We started our larger number 9 and we count on 3 more, as Elise gave 3 away and was left with 9 marbles. We know she had 3 more marbles than what she was left with. This is also related to the inverse relationship between subtraction and addition, and its important property of numbers and operations for future learning. So if we move these up here to the start, for example, we can see she has 12 marbles. And then she's going to give her 3 marbles to Dylan, which is our change. So we know that 12 minus 3 gives us 9. Because we started with 12 here, we subtracted 3 and we were left with 9. That part of our scale is balanced. You can also regroup. At the beginning, you can show the 12 marbles with 1 long and 2 units, for example. Our next problem is Elise had some marbles. Her friend gave her 8 more marbles. Her friend gave her 7 more marbles for her birthday. Then she had 15 marbles. How many marbles did Elise have before her birthday? So we don't know our start because we don't know how many sum is. We know our change will be 7 because she got 7 more marbles for her birthday. And our result is 15 because she had 15 total marbles after her birthday. This is a join problem because quantities are physically brought together. We're going to use a strip diagram to help us solve this problem. And with the linear model, numbers are represented as lengths on a number line. And then we are also going to make the connection between backwards counting and addition. So we will model that before we explain it. So we know we have 7 and another number, and we need to get to 15 total. So we're going to treat this as our number line. We don't write the numbers inside of the blocks or boxes because that would represent area and would later confuse students. So we know we can go 5 more. So 7, 8, 9, 10, 11, 12. So we're going to jump 5 more to 12. Oops, 5, and that gives us 12. And so we need to go a few more until we get to 15, 12, 13, 14, 15. So those were all jumps of 1, 13, 14, and 15. So if we add these values together, we have 8, and our unknown number is 8. So we know Elise started with 8 marbles before she got 7 for her birthday, giving her 15 total marbles. We can make a connection between backwards counting and counting down, or counting down strategies for our start unknown addition problem. Students can count in a backward sequence to find the unknown start quantity. Counting backwards is a previously learned mathematical concept and process for students. For example, in our join problem, we can start at the total number of marbles Elise had after her birthday, which is 15, and count backwards 7 numbers because that's how many marbles she received for her birthday. We want to know how many marbles she had before her birthday, which is 7 less than 15. This is also related to the inverse relationship between subtraction and addition. This is an important property of numbers and operations for future learning as well. Using set and linear models to help children solve word problems is to represent relationships visually. It is important that students experience all of these problem types and combinations of these problem types in order to ensure they have a broader understanding of the numeric structures. Also, recognizing how these problem structures are based on the described relationships between quantities will be crucial for them so that they may begin to develop mathematical modeling skills. And that was how to solve different problem types using the linear model and the set model.